Now see in this problem, this question is based on the equilibrium of the forces. Now see there is a string of length 2 meter, this is 1 meter, this is 1 meter, and a mass m is equal to 6 kg is hung over here. Now at the midpoint there is a 50 Newton force applied in the horizontal direction, and this remains in this condition, that is in the equilibrium. Now you have to find out the angle made with the vertical, this one. So how much angle this string make with the vertical, this we have to calculate. Now see here in this situation, first you see the number of forces acting at this point. See here mg is acting downside, that is equal to 6 into 10, that is 60 Newton. So tension is acting to this side, that is T2 upward. Here tension T1 is acting to this side and 50 Newton is acting to this side. So there are the three forces here, this is mg, 50 Newton and this tension T1. Now we can split this tension into two components, one is this side, that is T1 sin theta, and one is to this side, that is T1 cos theta. In equilibrium we know it, net force should be equal to 0. First we can take it here, T2 minus mg is equal to 0, that is T2 is equal to mg is equal to 60 Newton. So first we have solved this one, force on this m, that is this much 60 Newton. Now see horizontal direction 50 Newton, this side is T1 sin theta, so we can write T1 sin theta is equal to 50 Newton. That is also here remain here, that is both these forces should be equal. Now we can take here T1 cos theta, that is equal to T2, so we can write here T1 cos theta is equal to, that is T2 is equal to 60 Newton. Now if you divide these two, you will be getting here this and this first and this second. The first is divided by 2, you will be getting tan theta is equal to 5 upon 6. So you can write theta is equal to tan inverse 5 by 6. So that theta is equal to approximately it is coming 40 degree. So this is the angle made with the vertical.